Hi everyone, and welcome to this JavaScript tutorial to create the 1979 Atari game Asteroids, or our version of it at least. In this first part of the tutorial we're going to create the ship and make it move around the screen and everything. So you can go ahead and download this template if you like, update the title to whatever you like, Asteroids. We're going to use HTML canvas to achieve our graphical display. So give it an ID, game canvas or similar, give it a width. Width will equal, say, 700. Height, you can change this to whatever you like. Height will equal 500. First of all, we need to grab that canvas. Just from experience, I know that we need to give this a JS doc, so at type, just so that it recognizes it as a canvas element. So at type curly braces HTML canvas element, close the JS doc, and move to. Then we can create the variable canv, and that will equal the document. Get element by ID, and just type in the string that we had up there, the ID came canvas. Great. Get rid of this. We need to get the context from the canvas. So the context will equal the canvas.getContext, and it's going to be of type 2D. Good. We also need to set up the game loop to achieve our animation. We can just use the inbuilt function setInterval for that. It requires a handler, so that's just the function name, update, and a timeout in milliseconds, so 1000 divided by our frame rate. So we'll set up a constant called FPS. Const FPS equals 30 frames per second, say. So that'll be, we'll just leave a note, frames per second. So that means it'll call this update function once every 1/30th of a second. So let's go ahead and create that function update. Function update. What will we do first in this? Well, we need to draw. Let's plot out what we're going to do in this tutorial. So we'll draw the background, or draw space. We will draw our ship. We will, what else? We will move the ship. Move or rotate the ship first. Doesn't really matter the order here. We'll move the ship. Move the ship. Draw ship, draw space. Good. Okay, so first of all, we need to draw space. How do we do that? Well, we can just set up the fill style. Basically, we'll just paint the background in black. So fill style will equal black, and we'll draw a rectangle. So fill rectangle is to draw a filled rectangle, obviously. It requires the origin, which is just going to be 0, 0, and the width, which will be the canvas width. Canvas.width, and the height is the canvas.height. Let's just run that, make sure that it's working okay. There we go, that's the background, great. Next we want to draw a ship. Now, how are we going to represent our ship? Probably the best way is just by using we can just create a variable called ship using an object, a JavaScript object. All that is a fancy array, really. So ship will equal curly braces. Now we can put all our properties in here. So what do we need to know about our ship? We need to know the x-coordinate. So let's start it in the center of the page, center of the ship, center of the ship, center of the screen. So that'll be canvas width divided by 2. The y component will be the canvas height divided by 2. What else do we need to know? The ship size. So how about a radius? R, that represents radius. It'll be based on, how about we set up a constant here? Constant called ship size, which will equal, let's put it in pixels, say 30. Ship size, or ship height maybe, ship height in pixels. You could make this a percentage of screen width if you wanted to, or screen height, but we'll just keep it as a fixed number. So the radius will be half of that, won't it? Ship size divided by 2. We also need to know the direction of the ship, the heading as such. So we'll call that A for angle. Now if you know your trigonometry and the unit circle, 0 degrees is facing right. Facing upwards is 90 degrees. So we'll put it at 90 degrees. But all the math functions don't work in degrees, they work in radians. So we have to convert this to radians by doing divide by 180 and multiplying by math pi. Divide by 180 times pi, so don't need that. Convert to radians. Okay, so we have an angle. To draw that ship, well, we need to set up our context first, set up the colors and so on. So we'll have it as a stroke style. We'll just make it white. We will maybe set the line width. We'll set the line width. How about we put that as a percentage of the ship size? So that will be, say, ship size, say, divided by 20. Good. Now the actual ship. To draw a triangle, so this is going to be draw triangular ship. Draw a triangular ship. So to draw a triangle, we need to use the path. So we can do a begin path. Just call that function begin path. And we need to move the cursor to where we want to start. So we use the function move to. It just takes an x and y component, x and y coordinate. So the x coordinate will be the x of the ship, won't it? Well, the x of the ship represents the center of the ship, so we want to add something to that. Now what do we add? Again, some trigonometry. We just need to add the ship radius multiplied by the cosine, because cosine represents the horizontal, of the ship's angle, whatever that angle might be. Right? Similarly, the y component will be the radius times the sine. So that's the vertical of the ship's angle. We can test this out. Oh, actually, we'll have to draw a line first. So that's the tip of the ship. So that's the tip, the nose, I guess, the nose of the ship. Now we'd like to move to the rear left of the ship. So remember, it's a triangle, so context will do a line to. So it'll draw a line from the original point, from the to where? Well, the rear of the ship, we could use that to represent the rear of the ship, just with one minor change. Instead of, sorry, I just made a mistake here. Ship Y should be minus the ship, minus that, because negative represents upwards on the screen. All right. Now to get this, to get the rear of the ship, we would change the sign. So change the plus to a minus and the minus to a plus. So this will be the rear left of the ship. Now that's the rear center that we currently have, so we need to modify this. I just grabbed out a scrap piece of paper before and worked all this out using trigonometry. So you can either do it yourself or trust me. We need to add the sine of the ship's angle here. Right. And here we just need to subtract the cosine of the ship's angle. I'm not going to explain the maths here. I don't really want to do a maths lesson. Alright, so that should draw the rear left. Now to test this, we can just use context stroke. That means it'll draw the path. Let's have a look what that looks like. That's looking good. Do something similar, so copy and paste this. This is going to be the rear right. So we're going to draw a line to the rear right now. In order to do that, it's the same thing, except all we have to do is change the sign in here. Pretty simple. Let's have a look at that. Yep, it's drawn the rear of the triangle. And finally, we want to finish off, we want to close this. So there is an inbuilt command. I think it's called close path. There we go. And that should complete the triangle for us. Great. We need to test the angles though, don't we? So go back up to the ship's angle. Change, instead of 90, change it to say 55. So it should be facing right on an angle. Cool. How about 155? That should be facing the other direction. Looking good. And we'll go back to our original. Looks like it's working well. Great. I'm just thinking we should probably put the center of the triangle in just for our testing purposes. So we'll down here, center dot. We can do that just by setting up a context fill style, which will be, say, red, doesn't matter what color. And we'll draw a rectangle, so fill rectangle. The origin will be the center of the ship, so ship dot x -1, say we'll make it, say, 2 pixels wide. The ship.y -1, and the size will be 2 pixels by 2 pixels. Let's just see if that's there. Okay. Yep. So that's exactly how we've programmed it. The center will be exactly 1 radius from the peak and 1 radius from the bottom. But that's not really the center of a triangle. When we rotate this ship, it might not look very nice. So we could, the actual centroid of a triangle is a bit below that. It's 2/3 from its peak, I think. So we can fix that up pretty simply. So 2/3, we just need to, the nose of the ship would be 1/3 ahead. So we'll go 4 divided by 3 times that. So 4/3 times that. And this will be 4/3 times that, I think. Yeah. Remembering this is all in the radius, this is the radius of the ship, so that's why we're using 4/3 here. The rear, we just need to multiply the first component by 2/3 to get this working, I think. 2/3, yep. So this first component of each of these, just multiply it by 2/3. It'll shift it upwards, basically. Let's try it. There we go, and that's actually the centroid of so if you draw a line from this vertex to the center of that side, that's how you work out, anyway, you don't need to know the maths. That's where the center of the triangle, it'd be a much nicer experience. Good. So how do we go about rotating this ship? Well, we've got an angle. We need to update the angle when they push a button, say push the left arrow key. So we'll need to set up some what do they call them? Event handlers. Set up event handlers. So we can do that just by going document, add event listener, add event listener. It requires a type. So the type is one of these here. It's actually the one we're looking for is key down. So that means it'll detect when one of the keyboard keys are pressed. And the listener, well, that'll be the function we call. So we'll just call that key down. The same thing, really. When we push the left key, we want to rotate left. When we unpush the key, that means when we release the key, I guess, we also need to capture that event. So we can just duplicate that and use the key up. So it detects when the key has come up. And we'll make a function called key up. Right, so let's do that. Function key down. It will take an event as a parameter. So we can just use our JS doc again, just to make sure it's very clear that it's an event. At type, I think it's of keyboard, yeah, keyboard event. It is there, keyboard event. Keyboard event. Oops, we need that in braces. And then we just can, so look at that again. They just call it EV, so we can do the same thing, EV. Right, now we don't want any key to do something, do we? We don't want them to push the 6 or the question mark and something happens, unless you want to program it that way. But we just want to detect arrow keys. So to do that, we can make a switch statement. Switch. Oops, I didn't close this. There we go. Switch event.keycode. So that'll detect the key code, the actual code of the key that's pressed. The arrow keys are what we're interested in. So they start at number 37, I believe. So 37 for left, 38 for up, 39 for right. That's all we need to know, I think. So we can go case 37. I don't want to add event listener. We'll break that. And repeat this for each of the key codes that we'll be using. So we'll be using 38. We'll be using 39. And just probably write a note here. So this is the left arrow. And in brackets, what do we want it to do? We want it to rotate ship left. Okay. Similarly, we want 39, 37, 38, 39. Is it the right numbers? I think so. Rotate ship right. We'll soon work out whether it's right or not. This will be the right arrow. 38, that's the up arrow. And what will that do? That will, what's the term for shooting a thrust? Thrust the ship forward. Okay, we'll do that later. So first of all, how are we going to handle this? So we push the left arrow, something happens. How about we set the rotation of the ship? So in order to do that, we'll have to give another property. We can just call it ROT for rotation. It's currently equal to 0. We don't want any rotation. We should probably set up a rotation speed here, or a turn speed, whatever you want to call it. Constant turn speed. And we'll set it in, say, degrees per second. So I'll set it to, say, 360. And this is turn speed in degrees per second. Okay. So when the left arrow is pushed, we want to update the ship's rotation. It will equal the turn speed. Now that's in degrees, so we have to divide, to get radians, we have to divide by 180 times by math pi. And this will be, we want to get the per frame speed, don't we? So we'll have to divide by the frame rate. Otherwise it'll be rotating way too fast. Similarly, just copy and paste that, put that in the right. There we go. This will just be the negative of that, won't it? So we can set the rotation. When the right arrow is pushed, we'll just set the rotation to the negative of that. Now that won't do anything yet because we need to do something with this rotation. So down where we've marked rotate ship, all we have to do is ship.angle plus equals, should this be okay? It should be. Ship angle plus equals the ship's rotation. Ship.rotation. I think that should do it. Let's give it a go. Something's gone wrong. Plus equals the ship's rotation. Probably we can open up a console here to see the error. What does it say? Reference key up is not defined. Okay, so it wants to see all these functions written first. So function key up. It doesn't do anything yet. Although, actually, let's try. We may as well put this in now. Just copy and paste the same thing. So 37 left arrow, we want to stop rotating. So when the key is released, we want to stop rotating left. This will be stop thrust, or stop thrusting. And this will be stop rotating right. Okay, now all we have to do here is instead of setting a speed, we just set it to 0, so there will be no rotation. Right, now let's try that again. Just put that down, reload. There we go. Now, if I push the left arrow, yeah. Okay, something's not. It's rotating the correct direction, so when I push left, it's rotating. When I push right, it's rotating. That's fine, but it's not stopping. So something's going wrong here. I see, in our key up, we haven't put the event. It's a bit silly, isn't it? There we go. So the key up will detect an event now. Let's try that. So left, release the key, right, release the key. Yep, our rotation is working well, but nothing else is happening. We can't thrust at this point. So how about we work on that? Can you see the center of the triangle is more accurate? If you put it at the front of the ship, how we had it, would look a bit funny. So we've used the centroid. So thrusting, how are we going to handle that? Well, we'll have to give some more parameters, some more properties to our ship. So how about we say, we'll just put a flag in here called thrusting. So that's just a true false, a boolean. And we'll say it's not thrusting to begin with. And then we'll also have the thrust magnitude. So it can be simply, it can have its own component, the x component, which will be 0 to begin with, and the y component, which will also be 0. So we can set the thrust magnitude. This allows us to, when we thrust in one direction and we release the key, the ship will continue in that direction. Even if we rotate, it will continue in that direction. Okay, so up arrow, thrust the ship. Thrust the ship forward. So first, all we want to do in this, actually, when they push the up arrow, all it will do is set that thrusting to true. That's all it will do. Similarly, when they release the arrow, it will set the thrusting to false. Great. How about where are we going to thrust the ship? We'll fix it. We'll put the thrust here before drawing it, because we'll probably want to put a little graphical display as well. That'll be behind the ship. Not trust the ship. We want to thrust the ship. Okay. So to do that, we just need to set up a if ship thrusting. So if the ship is thrusting, we want to do something, don't we? We want to increase the thrust. So to do that, we can just go ship dot thrust. Now the x component, we want to add to it. As long as we're thrusting, we're going to add the thrust. So we'll probably need a base thrust up here. So how about the, let's call it ship thrust. We'll set it to something, say 5. We'll make this an acceleration. So this is acceleration of the ship in pixels per second A little bit of physics for you. So the ship thrust equals 5. So that means in the first second it'll go 5 pixels, in the second second it'll go 10 pixels, the third second 15 pixels, and so on. So it'll get faster and faster as long as you're holding that key. So the ship thrust will equal the ship thrust x component will equal the ship thrust, right? Multiplied by the cosine, because it's going to be the x component, the cosine of the ship's angle. Similarly, the y will just be the sine component. Let's see if that works. Oh, hang on, we haven't moved the ship yet, so it's updating the thrust component, but we have to use that thrust in order to move the ship. So what we need to do is the ship.x will plus equals the ship's thrust x. And the y component will plus equal the ship's thrust y component. So this means it'll keep moving as long as we're thrusting that way, or even if when we release the key, it should keep moving. Let's try it. I'm pushing the up key. Whoa, I know what I've done wrong. First of all, we got the wrong direction, right? So in this ship thrust, that'll be minus equals the x, no, the y component, sorry. Because it was going, the y component should be minus equals. And we haven't accounted for the frame rate, so just divide all this by the frame rate. Frames per second. Okay, let's try that. Pushing up. Yep, so I've pushed up. Now I can't pull back, I don't want it. You have to turn the ship in order to thrust it backwards. So turn the ship that way. To stop going that way, I have to thrust that way. probably will want some sort of frictional component. I know, depending where you are in space, there's not much friction, but for this game, I think we should have some friction. Otherwise, you'll forever zoom that way and never slow down. So to do that, what do we need to do? Let's add a friction constant. Constant friction. Friction. Now, usually friction coefficients in physics or whatever are a value between 0 and 1. So we'll set it up to, say, be 0.7. And we'll define that as friction coefficient of space, where 0 equals no friction, 1 equals lots of friction. Technically you can have a friction coefficient above 1, but we'll just stick to this. So 0.7. Now how do we apply that? So somewhere in our thrust, thrust the ship, somewhere in here we need to apply the friction node. So when it's thrusting, we want it to go forward. Otherwise, so that means they're not pushing the thrust key, they're not pushing upwards. When it's not thrusting, the friction will take hold. So to do that, we can just ship.thrust x. Now we just want to reduce this by a factor of itself. So we can just do friction times, remember it's a value between 0 and 1, so it'll get smaller, times the ship's thrust, so by itself, the x component of the thrust. And we need to divide that by the frame rate. Right, do the same thing for the y component, except change that to a y. I think that should do it. So it should apply this frictional component every frame and slowly slow down the ship. Let's try it. So I'll push forward a little bit, let go, and it's slowing down. Go that way, let go. Yeah, that seems about right. So I can turn around. I'm holding the arrow key while I'm turning here. Then I'll release it when I'm going on an angle, say, and it's slowing down. Great. The friction is working well. Now in the actual game, I think you can fly off the screen. So if I fly off the top of the screen, I'll pop back onto the bottom. So how are we going to do that? So we can handle the edge of the screen just after its movement. Handle edge of screen. So we need to detect when that happens first. So if the ship's x component, if the ship x is less than 0 minus the ship's radius, either way, we want to set the ship's x to where? We want to set it to the right of screen, don't we? So it'll be the canvas width plus the ship's radius. Right. Else, if the ship's x is greater than, basically greater than this here, so it's greater than the width of the screen plus the radius of the ship, we want to set it to this part, 0 minus the radius. Right, that's for the x component. For the y component, just need to change all of this to y, 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 and use height instead. Height instead. Let's give it a go. So thrusting upwards, turning a little bit. Yep. Pop back onto the screen there. Will it go this way? Yes. Going back the reverse direction. Zooming that way. Yep. Well, I'm going a bit fast. Slow down a bit. Seems to be working well. Great. Okay, that's our... I was just thinking, when we're thrusting the ship, maybe we want to add a bit of a graphic, like a bit of a thruster, like a bit of flame or something. So to do that, where we're thrusting the ship, we'll just need to draw something here. So draw the thruster. Right, so the thruster will be a triangle. So we'll just copy and paste this one. Just get that indentation. There we go. What stroke style are we going to have? Well, I'm thinking yellow. And we'll probably have a fill style as well. I've got a comma there, that's not right. Let's change that. It's amazing it's working okay though. We'll have a fill style as well, so that'll be the interior, the flame as such. Fill style will equal red. You can customize these colors how you like. The line width, probably a bit thicker, so we'll make it 1/10, so the ship size divided by 10. Begin path. The nose of the ship, it's not where we want to thrust behind the ship, so to do that we need to change this to a negative, change this to a positive. Now that'll be the center of the ship. Actually, I'll copy and paste this second pass. We'll start at the rear left first, so we'll start at the rear left, paste that in there. So move to, so this will be the rear left. We want a line to the rear center, which is behind the ship. So this will be behind the ship. Behind the ship. Okay, so that's all correct, except that we want to do it behind. So to do it behind, we just need to multiply, we'll times that by 2. We'll make it 4/3. We don't need this here because it's the center, so we need to get rid of that. So lots of confusing maths, I know. So it'll just be the cos and the sine, and 4/3 of it to be behind the ship. So maybe times 2, we'll make it 8/3. There you go. That'll be twice as the length of the ship behind it. So near center behind the ship, rear center behind the ship. Now the rear left, that's correct, except that we want, we'll see what that looks like first. Now we need to also draw the fill here, so the context fill. Let's try it. Now when I thrust, whoa, it's huge, isn't it? Maybe it's a bit too huge. Let's bring the triangle in a little bit. So to do that, we can, okay, first of all, it's too far behind it, so we'll change it to 6/3, say. Now to get it a bit thinner, we could just put a multiplier in here, say 0.5, multiplier in each of these, the left component, the rear left, and the rear right. So hopefully that'll bring in the, let's try. Yeah, that's looking pretty good. You can make your own sound effects. We probably will add sound effects later. That looks pretty cool. You can adjust the size of it however you wish. Maybe you could just go with 4/3 here. What will that look like? Bit too small, isn't it? Depends what you like. I'll put it back to 6/3. Sounds good. Great, that's the thruster. Is there anything else we need to do here? I think we're pretty much, hang on, reload that. I think we're done for this tutorial. You can turn off the center dot. Just need to, where is the center dot? Here we go, just stop drawing this. And we have our Asteroids ship that can go around and around, thrusting along. We're going to create the asteroids themselves that float around the ship in space. So currently, this is what our game does. We have a little ship that flies around the screen. Wouldn't it be nice to have some asteroids floating around it? So here's our code. You can go ahead and download this from the link below. So the first step would be to set up our Asteroids variable. So just underneath where we set up our ship, we can create, or how about we set up Asteroids. So that'll just be a variable. We'll call it roids just to keep it short. Roids equals a blank array. And how about we create a function called create asteroid belt? Because during the game we'll probably have to call this a couple of times as we reset the screen and so on. Create asteroid belt, that'll do. So go down and set that up somewhere. Here we go. Function create asteroid belt. Now what does it do? Probably the first step is to clear our clear our roids array. Roids will equal that. So I'm just clearing it because it may be populated during game. Secondly, we want to loop over the number of asteroids that we'll be creating, don't we? So we could use a loop for that. So for var I equals 0, I is less than what? How about we create a constant? So up the top, just create a constant. We'll prefix all these by roids. Yeah, roids num. And we'll say there's 3 of them. So this is the starting number of asteroids. I say starting because as the difficulty increases, we'll probably be increasing this as the level goes up. Roids num. So I is less than roids num, I++. So that'll loop over all the asteroids. Now we want to add roids push. That'll add something to our array. How about we create a function called new asteroid? Again, we'll probably need this for later on. New asteroid. Yeah, we'll try that. So we'll go make that down here. Function new asteroid. We can create a variable called roid. It's going to be an object. And we'll return that object, return roid. Now what do we need to know for each asteroid? Well, we need to know an XY coordinate. I think we should pass the X and Y components because later on in the game we'll need to know the exact location. So X will equal X, Y will equal Y. We'll need to know an X velocity, which is going to be some random velocity. How about we set up a constant soon called roids speed, and we'll have to divide that by the frame rate. We also want a random direction. Not only do we want a random magnitude, we want a random direction. So to achieve that, we can go math random. If math random is less than 0.5, then multiply by 1, so it'll go in a positive direction. Else multiply by -1, it'll go in a negative direction. We can just copy and paste that for the Y component as well. We'll also want to know the radius of each asteroid. It will change as we shoot them later on, and that'll just be based on some roids size divide by 2. And we'll also want to know a random angle. So this has to be in radians. So math random times math pi times 2, which is the same as 360 degrees. So this will be in radians. So let's go ahead and create these size and speed, roid size and speed up here. So roid size will be, let's say 100. So this will be the maximum starting size. No, we'll say the starting size of asteroids in pixels. Okay, roid speed. I'm just taking some guesses here about what sort of speed we want. Put it in pixels per second, so this will be the max starting speed, not peed, speed of asteroids in pixels per second. Okay, so we've got the starting size of asteroids in pixels is 100, and the max starting speed of asteroids in pixels per second, which is 50 pixels per second. That looks good. Because we're passing X and Y, we'll have to go and modify our call up here. So there'll be some X and Y value that we'll put through there. Now what's that going to be? We can just create two variables here, var X and Y. How about we just create two random positions on the screen? So that'll just be math random times by canvas width, canvas.width. We'll probably want to round that down. Math floor. And do a similar thing for the Y direction, except that we'll be using height. I can think of one problem here. We're potentially going to have asteroids landing on the ship. We'll handle that soon. Right, now let's go down to the update function. So where we draw our ship, after that we'll draw the asteroids. So we'll have to loop through each of the asteroids in order to achieve this. So var I equals 0. I is less than the roids.length. Length is just a property, I think. And I++. First of all, let's set up the color of the asteroids. Stroke style will equal, I looked this color up before, slate gray, just to get them a bit of a different color from the ship. And we also need to set the line width. Line width will equal, we can base it off ship size, I think. Ship size divided by 20. Now let's plot out what we're going to do here. How are we going to draw these things? Well, I think we need to draw a path. Draw a path. What shape are they going to be? Probably a polygon would be suited, so draw the polygon. We'll work out these details soon. And we also want to move the asteroid. Move the asteroid. And handle edge of screen. So we don't want them floating off into space, do we? Edge of screen. Good. Now let's go back up to where we create our asteroids. So we want to create a random number of sides. So we can achieve that by, we'll make a property called vert, short for vertex or vertices. So it'll be math random times, we'll make a constant called, say, math roids vert. Now, in order to achieve what we want a random number of sides, but we don't want sides equal to 0 or something, do we? So let's first of all add 1 to this to increase our maximum to what we expect. So that'll be, just say roids vert equals 10, so that'll give us a number between 0 and 10. As I said, a zero-sided polygon is no good, so we'll have to add something to this. How about we add half the roids vert? So that'll be 5, for example. We'll need to find the floor of all this to make it an integer, floor. We don't want 3.5 sides, for example. So that'll, if roids vert equals 10, that'll give us a random number between 0 and 10, plus half of 10, which is 5. So a random number between 5 and 15, centered around this number. Sounds good. Don't need the semicolon again. So let's go ahead and create that. Roids vert will equal 10. And this will be the average number of vertices on each asteroid. Okay, so head down to our update function. So each asteroid will have a random number of vertices. All the way down here. There we go. Draw a path. Right, so to draw the path, we need to context begin path. And then we want to move to the first point. So move to the first XY location. Now I'm thinking to save us a little bit of time, we should probably get the properties, grab all the properties and put them into a variables here. So get the asteroid properties, just to save us a little bit of typing, I think. So we'll set up some variables here, x, y, the radius, the angle, and the number of vertices. So x will equal roids I dot x, and then we can go ahead and do the same for all our other things. So y will be the roids I, right, roids y I should say. The radius will be dot r, the angle will be dot a, and the number of vertices will be dot vert. Okay, so our initial point will be the x location, the center of the asteroid, plus the radius multiplied by the cosine of the angle. Similarly, the y component will be the sine, radius times the sine of the angle. Now, to draw the polygon, we'll have to loop over the number of vertices. So we can set up a new variable to say j will equal 0. J is less than the number of vertices, j++. And we'll want to draw a line to each corner of the polygon. So context line 2, line 2. So in a similar way to what we've done above, so x plus the radius times the cosine of the angle, but we'll have to modify it based on which vertex we're currently at. So we could do that by modifying this by j times 360 degrees, math pi times 2. But we'll have to divide that by the number of vertices, right? So that'll, for example, if there was 10 vertices, then this will modify the angle by 36 degrees each time, which is what we want. Do the same thing for y, except that we need to change it to sine. After that, we'll have to close the path and draw it by just going context.stroke. Stroke. Right. Just a quick review of our code, just make sure there's no glaring mistakes. So we're going to create the asteroid belt. That should be a 0, not an O. Divide by that. Math for random times that should probably be canv, not canvas. Right, and then they'll push some new asteroids, set up some properties. I think that's pretty good. And then we'll draw them down in the update function down here. Let's try it. There we go. So we've got some randomly positioned polygons from size 5, so 5 sides to 15 sides, I guess. Let's see if we can get a 5-sider one. There's a 7. Just to make, there we go, there's a pentagon. Awesome. But as I mentioned earlier probably, is that we don't want the asteroids to appear on the player like that. So let's go ahead and fix that up now. We can do that up in our create asteroids method, create asteroid belt. Here, we'll have to do something here. We can handle this using a do while loop. So do all of that while some condition. Now, what is the condition? We want a buffer, don't we, between the asteroid and the ship. So how about we create a function called distance, or dist between points. Distance between points, and we're going to pass each of the coordinates. So the ship's location, ship X, ship Y, and the potential asteroid location, X, Y. Now, as long as that is less than some buffer, so we'll just say the roids, base it on the roid size, say times 2, plus the radius of the ship. As long as it's less than that, if it's less than that, we'll keep creating new random points until it's not less than that. So let's go ahead and create this function. Distance between points. Now what are we passing? We're passing the points. So x1, y1, x2, y2. Alright, so we're going to return. Now if you know your Cartesian coordinate system, it's the square root of the square, so math power, the square of x2 minus x1 minus x1 squared, plus, similar thing with the y component, y power, y2 minus y1 squared. That should be okay. Let's try it. It's hard to tell because there's only 3 there's only 3 roids. How about we bump this up to say 300? There we go. See that buffer zone? So they're being randomly placed, but they're not being randomly placed within our buffer zone. You could adjust that to suit your taste. How pretty. Put that back to 3. Great, that's that handled. Okay, so what about the shape of these asteroids? So just have a look at them. They're perfect polygons, aren't they? Not exactly very asteroid looking. So let's add some jaggedness to this. So how about we go up and create a constant called roids jag, and let's define that to be a number between 0 and 0.1. So let's pick a number, 0.4. This is the jaggedness of the asteroids. And let's define that as 0 equals none, 1 equals lots. Okay? Now where we create our asteroids, so in new asteroid, let's create some variable, some property, which modifies the vertex location. So each vertex will be 1 radius away from the center. How about we create, say, an offset? So offs, that'll do. Offsets is just going to be an array. And let's set up the array here. So create the vertex offsets array. Okay, so it'll be based on the size of the number of vertices. So var I will equal 0. I is less than the roid dot vert I plus plus. So we'll loop through for each vertex and create a random sort of multiplier to the radius. Okay, so the maximum we'd want so the minimum we'd want is 0, and the maximum maybe, say, 2 times the radius. So that would be in the most extreme situation. So let's go roid.offsets push. We're going to push a random number. Random number based off the jag, so the roid's jaggedness. Now, how are we going to handle it if it's 0, we want nothing. We just want it to be all of this to equal 1. If it's 1, it could potentially equal 0 to 2. So how about we times this by 2 and add 1 minus the roid's jaggedness. Now, does that work? Let's have a think about this. So if it was 0, 0 times 2 is 0, so there'd be 0, plus 1 minus 0, 1. Okay, that works fine. So there'd be no jaggedness. If it was maximum, so if this equaled 1, we'd have 1 times 2 is 2, so 0 to 2, plus 1 minus 1 is 0. So it'd be a random multiplier between 0 and 2. That sounds good. How about in the middle, 0.5? 0.5 times 2 is 1, so 0 to 1, plus 1 minus 0.5. That would be a random number between 0.5 and 1.5. Sounds good. So we're populating this offsets here. Great. Now how do we handle that? Let's go down to the asteroids here. All we have to do is multiply this radius here by that offset. So how about we create up here, that should be vert, doesn't really matter, it's obviously declaring it anyway. Offs will equal roids I offs. Okay. Now, the first point is going to be, so this will be the radius times the offs. It'll be the first position, won't it? The offs 0. So whatever that random multiplier is, it's going to multiply the radius by it. And we're going to do a similar thing to here. Now, how about here? Well, it's not going to be 0, it's going to be j, isn't it? It's going to be j in here. But we've already done j equals 0 up here. So we don't, how about we start 1 here? So we'll start j at 1. Yeah, that should work. Now let's have a look at, see what that looks like. Looking promising. Actually, it's looking pretty good. Looking very good. Okay, I think we solved it. So let's go test different values of jaggedness. Say let's do the extreme. So 1. What will that look like? Yes, you can see here they're very jagged. Okay, now if it's 0, there should be no jaggedness. It should be a perfect polygon. Yep. And then as you add more jaggedness, so 0.1 should be a little bit jagged. Yeah, just a little bit. Depends what shapes you want in your... I'm going to go stick with 0.4. That looks pretty good to me. Awesome. Now all we have to do now is move these things, get them moving, go down to where we had... where are we? Draw the polygon, close, move the asteroid. So that'll just be roids I dot x plus equals roids I dot xv. That's the velocity in the x direction. Similar for the y direction. Let's just, oops, this is probably one of the easier parts. Let's just check to make sure they're moving. Yeah, so they're going at random speeds. We could probably bump up the number of roids to begin with, just to see if, say 10. Yeah, they're definitely going at different speeds, different directions. Cool. And the color's quite nice, isn't it? Awesome. Let's put that back to 3. We also want to handle what happens when they go off the edge of the screen. So currently, if you look at these asteroids, they go off the screen and then they disappear forever. Let's bring them back onto the other side of the screen. Handle the edge of the screen. So if roids I dot x, if that's less than 0, minus roids I dot radius, if it's less than 0, then it's gone off the left of the screen. So we want to set roids I x to equal the canvas width plus the roids I radius. Yeah. Else, it's not really an else, it's probably more of an else if. Else if this situation, roids x is greater than the canvas width plus its radius, then we want to set to this. Roids x will equal that. That's for the x direction. Do a similar thing for the y direction. So y, except it'll be based on height, won't it? Height. Let's give that a go. Okay, going off screen, this right one here, will it pop back on? Yep, there it is over there. There's one going off the bottom of the screen. Is it coming back on? Yep, there it is. So they're coming back on. We can bump up the number of asteroids just to get a good feeling for it. Roids number 10. There we go. So one went off the top up there, one's going off the side here. Good. I think that's looking good. So that's the end of today's tutorial. Next time we'll focus on collision detection and making this ship blow up when it hits an asteroid. So in this tutorial, we're going to allow the ship to crash into the asteroids by using collision detection. So you can go ahead and download this code. I'll have it in the link below. So let's go ahead and create a flag called show bounding. Now this show center dot I created off camera. It's just a way for us to not delete code or not comment out code. So we can always allow our development settings to stay there. So for example, show center dot, if show center dot, draw the center dot. But we don't want that normally during gameplay. So it's a nice convenient way to turn that off. And we're going to do the same thing with our bounding boxes or our bounding circles. So set that to true to begin with. Show or hide collision bounding. So how are we going to represent our collision detection? What shapes are we going to use for our bounding boxes? Well, take a look at the game. I'm thinking the simplest way is probably to just use a circle for everything. So our ship would be represented with a circle, and each asteroid would be represented with a circle. It's not exact, but it's a close approximation, and I think it will do for such a high-speed, simple game. So let's go ahead and use circles. So let's draw our circle down in the update function where we draw our ship. So draw the triangular ship. Just after we do that, we will say if show bounding. So if our bounding flag is on, we want to set the color. So the stroke style will equal, say, lime. Pick a color that stands out. We want to begin a path because that's how we do a circle. And context.arc. Now we need a center point, which is going to be the center of the ship. So ship.x, ship.y. And then we're going to use the ship's radius. The start angle is 0. The end angle is 360 degrees, which is just math pi times 2 in radians. And false for that final flag. Finally, we just need to draw the stroke itself. Let's test that out. Yeah, so we've got a bounding circle around our ship. Similarly, we want to do the same thing for each asteroid. So go down to where we draw the asteroids, just after we draw it, before we move it. Paste that in there. But instead of ship.x, we just want x, because we've already declared x to be the ship's x, sorry, the asteroid's x, y and r. Let's test that out. Yep, so each asteroid's got a circle around it. The only problem is that the color of the circle's gone through to the asteroid. We can fix that up by just changing where we set the color of the asteroid. So currently we're setting it before the for loop. Just paste that into the start, at the start of the for loop. So it'll do it every iteration. Give that a go. Great. So what's our goal? Our goal is when the circle of the ship touches the circle of any of the asteroids, the ship will blow up. So first things first, I think we'll need to take out the moving of the asteroid. So how about we just stick to our drawing? So in our update function, we're drawing the ship and we're drawing the asteroids. Let's take out the movement and put it elsewhere. So here we're rotating the ship and moving the ship, so we'll place the asteroid stuff after that. So move the asteroids. We'll have to do another for loop here. For var I equals 0. I is less than roids.length. I plus plus. And just encapsulate that. And test it to make sure that we haven't broken anything. Yep, it's still working. So the asteroids are still moving. Next, we want to check for collisions, for asteroid collisions. So just copy this first line of the for loop. Now before we start moving everything, so before we start rotating the ship, let's check for asteroid collisions. Right, so we're going to cycle through every asteroid and check whether the distance between, so this is a function we made before, distance between points. So the ship's x value, the ship's y value, and the asteroid, so roids I dot x and the roids I dot y. So if the distance between the individual asteroid and the ship is less than the ship's radius plus the roids radius, so the asteroid's radius, that means the circles have overlapped. What will we do there? How about we just call a function called explode ship, which we haven't made at the moment. So if we run this now, it should try to call this function and break. It should stop working. So let's try it. Right, so we've got the ship. Let's try to crash into an asteroid. Yeah, it's broken. So as soon as those two circles met, it's tried to call that function and broken. Good. That means it's working. Okay, let's create that function explode ship. First of all, just copy this this code here to create a circle. So up in this function, so function explode ship, let's just create a circle. Let's create a filled circle. So it's an obvious sort of graphical indication that the collision detection is working. So create a fill style, the same color, lime. The X and Y coordinate will be the X and Y of the ship, as well as the radius of the ship. And we'll also call the fill method. So we'll be calling a fill and a stroke. Let's test that. So when we collide into a asteroid, come on asteroids, where are you? There's one down there. We should change to a filled circle. Awesome. And when we leave, we're no longer filled. Good. That means our detection, our collision detection, is working very well. Great. Okay, what do we ultimately want to do here? I'm thinking we should set, so I'll just cut this. I'm thinking we should set some property of the ship. Let's call it, say, explode time. Explode time. And that will equal, we'll say it's equivalent to the number of frames left in the explosion. So that'll equal some constant, say ship explode, say duration, multiplied by, so that'll be in seconds, multiplied by the frame rate to get the number of frames. Because we want an integer, we should probably find the, so let's say seal, we'll round up in effect. Okay, so let's create this ship explode duration constant. Ship explode duration, and it'll be in seconds, so just choose a number, 0.3. So this will be the duration of the ship's explosion. Right, where we set up the ship initially, we'll have to give that an explode, what do we call it? Explode time. Initially it'll be 0, won't it? That means there'll be 0 frames left of exploding. And that's how we're going to detect whether the ship is exploding or not. When explode time equals 0, it's exploding. So go down to the update function. How about the first thing we do? Just create a variable. So it's going to be a boolean called exploding. And that'll equal ship.explode time equals 0. No, greater than 0. So if the ship's explode time is greater than 0, that means the ship is exploding. Okay, so where will we draw this explosion? I'm thinking instead of drawing the ship, we'll draw the explosion in its place. So if not exploding, we'll draw the ship. Else, we'll draw the explosion. What will the explosion look like? Well, I'm thinking just some circles to keep it simple. So here, we'll copy and paste this code here. But we'll use filled circles. So fill style will equal red. The ship's radius, how about we try times by 1.5, say. And we need to call the fill method. And how about we work inwards? So we'll start with the outer circle, which is red, and then we'll make, say, 3 more. Red, orange, yellow, and say white for the middle. We'll change these radius percentages. How about we'll decrement it by 0.3 each time. So 0.9 here, and 0.6 for the inner circle. Let's take a look at that. Crash into a asteroid. It's looking okay, maybe a bit big in the middle, and maybe we need another ring on the outside, I think. And we'll get rid of that bounding, so I'll turn that to false, show bounding. Explosion, where are you? Here we are. So what did I say? Maybe make it a little bit less in the middle, so reduce that by 0.1. So that'll be 1.1, that'll be 1.4. And we'll also do one more ring on the outside, a bit of a darker red. I assume dark red is a HTML color. And change that to 1.7. Let's see what that looks like. So there's no bounding circles now. Let's crash. Yeah, that's pretty good, I reckon. We'll stick with that one. If you go back to our game, just restart that, you'll notice that when we crash into an asteroid, we can continue moving and our thruster is still working. That's not what we want. We kind of want to stop in place and just explode. Okay, so let's fix that now. So let's go up to our thruster. So just up here, draw the thruster. We don't want to do that when we're exploding. So if exploding, that should be if not exploding. If we're not exploding, then we're happy to draw the thruster. Okay, let's try that out quickly. Yep, so there's no thruster coming out the side or the rear of the explosion. That's good. Also, we don't want to be moving the ship. So go down to where we move our ship. Here we go, rotate the ship, move the ship. We also don't want to be checking for asteroid collisions, so we can include that in here. So if not exploding, we don't want to rotate, we don't want to move, and we don't want to check for collisions. Let's test that. So I'm pushing forward, bang. I'm still pushing forward, trying to turn, nothing's happening. Great. So what happens when the ship is exploding? Well, we can handle that here in an else. So else the ship is exploding. We want to take the duration of the explosion into consideration. So we can do that by ship.explode time minus minus. So we'll reduce the amount of time left on the explosion. Now what happens when that reaches 0? So if ship.explode time equals 0, that means we should end the explosion. So how about we create a new ship? So ship will equal new ship. Now new ship's just a method I'm just creating. Well, we'll go create that now. So new ship. Now all it will do is basically this. So where we set up the initial spaceship, we'll just cut that. We can change that to new ship. Go down to where we, just after new asteroid, we'll create new ship. Function new ship. And what does it do? It just returns that thing that we had copied. Okay, let's test that. Okay, so we'll fly our ship into an asteroid. Bang. And we're resetting. Now there is one issue with this. What if the asteroid is coming towards our initial restart position, like this? Bang, 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 bang. That's no good, is it? How the original game handles this is by allowing the player to blink for a few seconds before they start the game, and this prevents any explosions from occurring, so like an invulnerability or an invincibility or something similar. So let's implement something like that. We'll need to go up the top and set some parameters here. So how about we have an invisibility duration, or invulnerability duration. We'll set that to say 3 seconds. Duration of the ship's invisibility in seconds. And we'll also want to know how long is each individual blink during that invisibility. So we'll call that, say, ship blink duration. And it can equal, say, 0.1 second. So 0.1 second it will stay off, 0.1 second it will turn back on. Duration of the ship's blink during invisibility in seconds. Okay, go down to where we create our ship. We'll need to set up a couple of properties here. So we'll have one called, say, blink time. That'll be we'll round up, so math seal. It'll be equal to the ship blink duration times the frame rate. So the frame rate's 30, right? Blink duration is 0.1, so there'll be 3 frames. Every third frame it'll blink on and off. And we'll also want to have the blink number, keep track of the blink number. So that will be equal to the ship invisibility duration, so that's 3 seconds, divided by the ship's blink duration. So that'll be a total of 3 divided by 0.1, so 30 blinks. So there'll be 15 off and 15 on. That sounds good. So just down below in our update function, let's create another variable called blink on, say. Blink on, and that will be equal to, well, let's say that when the blink number is even, then we'll be blinking on. When it's odd, we'll be blinking off. So we can handle that by using, so ship.blink num mod 2. When that equals 0, so when the remainder of dividing that by 2 equals 0, that means it's an even number, else it's an odd number, right? So where we draw our ship, so if not exploding, inside there, so if blink is on, if blink on, we want to draw the ship. And how about underneath that we handle the situation, we'll just say handle blink, handle blinking. So we need to, so if the ship blink number is greater than 0, that means we have to do something here. How about we reduce the blink time? So that's what's keeping track of the blink duration. So blink ship dot blink time minus minus. And we also want to reduce the blink num. Blink num. Reduce the blink num. So that's if ship dot blink time equals 0. If that equals 0, then we want to, well, we have to reset that, don't we? So ship.blink time will equal math.ceil, rounding up, the ship's blink duration times the frame rate. And we'll also decrement the blink num. So ship.blink num minus minus. Hopefully that should work. Okay, it's a blink, and it lasted a number of seconds. So let's see if that works after we smash. 1, 2, 3. Yep, good. It seems to be working. The only thing we haven't done is that we haven't incorporated invulnerability yet, have we? We haven't changed the collision. We haven't included blink in the collision control. So let's deal with that now. So let's go down to where we handle collision control. Move the asteroids. Here we go. So check for asteroid collisions. So we only want to do that if the ship's blink num equals 0. So that means we're not currently blinking. If the ship's blink num equals 0, we'll handle collisions. So if it doesn't equal 0, it'll ignore collisions. It'll make us invulnerable. Let's test that. We'll probably need to bump up the number of asteroids a bit. So asteroid num, let's make 30. Okay, so we're invulnerable. Bang. Yep. Bang. So we're invulnerable while we're blinking. Oops. Let's see if I can not hit one. Good. So I'm not just blinking all the time. Bang. Now I'm invulnerable. Oh, one thing I noticed is that our thruster is still not blinking. We should probably make that blink. Let's go back and fix that. So just reduce that back down to 3. Head down to where we draw our thruster. So draw the thruster, if not exploding, and blink on, then we'll draw the thruster. Let's test it. Yep, so our thruster is blinking as well. Let's crash into an asteroid. Bang, are we still invulnerable? Yes. Just smash into an island. Yep, everything looks to be good. So that's the end of today's tutorial. So we've looked at collision control and blowing up the ship. Next, we'll focus on shooting. So using the laser of the ship by pressing the spacebar and blowing up asteroids. Currently, our code allows us to fly a ship around and smash into asteroids. But apart from that, we can't do anything else. So in this tutorial, we're going to create a laser effect. So we'll be able to press the space bar and shoot these pesky asteroids. So you can go ahead and download this code if you don't already have it. First of all, let's create some constants. How about we create one called laser max. So that'll be the maximum number of lasers on screen at once. We'll set that to say 10 to begin with. So that'll be maximum number of lasers on screen at once. And we'll also have, say, the laser speed, because we'll need to know how fast these little things travel. We'll put that in, say, pixels per second. Speed of lasers in pixels per second. So how will we detect when the spacebar is pressed? Well, we can go down to where we detect our other key presses. So in the key down method, just copy and paste one of those cases there. The key code for spacebar is 32. So let's label that space bar. And what will it do? It will shoot the laser. So let's just create a function name here, shoot laser. There we go, we'll implement that after. Now in the key up method, so when the spacebar is released, what should we do? Well, I'm thinking when we press the spacebar, we should lock the shooting. So you can only shoot once per press. So here, we should allow shooting again. So when we release the spacebar, let's allow shooting. So we could probably handle that with a property on the ship called, say, can shoot. And we'll set it to true here. Can shoot equals true. Let's go down and add that to the ship now. So in the new ship method, can shoot, it should start off as true, shouldn't it? We want to allow shooting to begin with. We'll also need to keep track of our lasers, so they can be kept track of here in the ship. And it's just an empty array to begin with. So just below, let's create our shoot laser function. So function shoot laser. In that, we want to create the laser object. And we also want to prevent further shooting. That's fairly simple to manage. Just go ship.canShoot equals false. Now, before we add a new laser object, we want to check a couple of things. So if, one, the ship can shoot. So if the ship can shoot, and the ship.lasers array, the length of that is less than our laser max. All right? If both of those conditions are true, we can safely add a new laser. So to add a new laser, we just go ship.lasers push. We'll want to put this in curly braces because it's an object that we'll be creating here. We'll need to know the x coordinate and the y coordinate. Where will we be shooting from? I think we'll be shooting from the nose of the ship. So from the nose of the ship. And we have used that code before. Just need to go down to where we draw our ship. Where is it? Here it is, nose of the ship. So just copy both of those there, the x and y coordinates. Paste them in there. That'll be the y. Just need a comma there. We'll also need to know the x velocity, which will be based on the laser speed times by the cosine of the ship's angle. Lots of trigonometry in this. Divided by the frame rate to get pixels per frame. And similarly for the y velocity, except that it'll be the sine of the ship's angle. So let's go down and draw our lasers. We can do that after we've drawn our ship. So just after the collision circles there and the center dot. So draw the lasers. So we'll have to use a for loop. Var I equals 0. I is less than the ship.lasers.length. I++. We'll have to set the context fill style. I'm thinking we'll draw small circles to represent the lasers. Now check some of these colors out before, so I'm just going to use salmon for the laser color. It's quite nice. We'll need to begin the path to draw a small circle. And we'll need to use the arc method. Arc, and we need to know the x, so it'll be the ship.lasersI.x. the ship.lasers_i.y. The radius, we'll base that off the size of the ship. So we'll go ship size, say, divided by 15. The start angle is just 0. The end angle is math pi times 2, which is effectively 360 degrees. The final flag doesn't matter. And we'll need to call the context fill method to draw this. Let's just test that. Now they shouldn't move at this stage. Cool. So they're appearing at the nose of the ship. That's promising. And we should only be able to do 10 of them. Yep. Great. So let's go down and move the lasers. So just after we move the ship, move the lasers. Again, we'll need to use a for loop. So for I equals 0, I is less than the ship lasers.length, I++. So what we'll need to do here is just go ship.lasers, I, the x position, plus equals ship.lasers, I, xv, which is the velocity in the x direction. Similarly, for the y, we just need to modify it by yv. Let's test that. So shooting lasers, oh, not quite going in the direction we want. I see the problem. I'd guess the y, so back up where we shoot our lasers. Shoot lasers. I see, the YV needs to have a negative there because negative is upwards on the screen. Let's give that a go. Great. Now the only issue is that once we run out of those 10 shots, there's no more. They're forever flying off into space. So let's fix that up now. The first thing we can do is handle the edge of screen. So just go down to where we move our laser. Draw the lasers. Move the lasers. Handle edge of screen. So we've done this a fair few times with other objects. So all we need to do is say if, I'll just copy this, make it a bit easier for me. If the laser's x position is less than 0, then we just want to set it to equal the canvas width. Else if the laser's x position is greater than the canvas width, then we want to set it to 0. Copy all of that. We'll do the same sort of thing for the y position. The y position, the y, and instead of the width, we'll use the height. Okay, let's give that a go. Shooting some lasers. Yep, I can only shoot 10, and as you can see, they forever fly around and around the screen. So what we'll probably need to do is set some maximum distance they can travel, and then they kind of fizzle out, or just dissipate or whatever. So let's do that now. Firstly, let's go all the way up the top, and create a constant called, say, laser distance, or just laser dist. And let's make it a fraction of screen width. So choose a fraction, I'm going to say 0.6. And we'll define this as max distance laser can travel as fraction of screen width. We'll also need to set up a property on the laser. So go down to shoot laser. And just here we'll add a property called distance traveled. And we'll start it at 0. So let's head on down to where we move our laser. Move the laser just after where we update its position. Let's calculate the distance traveled. So ship.lasers_i.distance plus equals. Now we'll have to use Pythagoras' theorem here. So a squared plus b squared equals c squared. So the square root of the square, so math power of this here, the x velocity component, that's what we're adding each time. So the power of that, the square of that, plus math power the square of the y velocity, all square rooted, should give us the distance. And what do we need to do with that distance? Well, before we move our ship, so this will be move the, it's not the ship, is it? Move the laser. We'll want to check distance traveled. And we want to delete the laser if this happens, don't we? So if ship.laser.distance is greater than the laser distance, now that's as a percentage of, as a fraction, so times the canvas width. If it's greater than that, then that means it's gone far enough and we want to delete it. There's a couple of ways we can delete from an array. I'll be using the splice command, so ship lasers splice, and splice takes the start number, which is going to be I, and the delete count, which is just 1. We just want to delete one thing. Now the issue with splice is that it permanently changes the size of this array, meaning our for loop will have some problems. So we can get around this by, instead of going forwards in the loop, we'll go backwards. So var I will equal the length of the array minus 1, and we'll go until I is greater than or equal to 0. And instead of incrementing, we'll decrement, so I minus minus. So that'll be removed, so we won't want to continue in this. We won't want to try to move the laser because it won't be there. So we'll write the continue command. Now all that does, it skips over the rest of this and goes to the next iteration of the for loop. So that should be okay. Let's give it a go. Shooting lasers. Yep, they are not going on forever. How about we change it to something a bit smaller? So the laser distance will change to something a bit smaller, say 0.2, just so we can get a real good feel for it. Shoot some lasers. Awesome. So we can unlimitedly shoot these lasers because they're destroying themselves after they reach 0.2 of screen width. Let's just change that back to 0.6. Now we need to detect when the lasers actually strike the asteroids. So head down to our update function just under where we draw our lasers. Draw the lasers. So we'd like to detect laser hits on asteroids. Right? I'm thinking we'll probably need to use some variables here just to make it a bit cleaner. So we'll have the asteroid X, the asteroid Y, the asteroid R, the laser X, and the laser Y. So we'll need to do a for loop backwards again because we'll be removing asteroids. So we'll have var I will equal roids.length minus 1. I is greater than or equal to 0. I minus minus. Right, so we can grab the properties of the, grab the asteroid properties. So AX will equal roids, roids I dot X. Similarly for the other ones, so AY, the asteroid's Y will be that, and the asteroid's radius will be that. Okay, now we can loop over the lasers. Yeah, so we'll have to go backwards with this one as well because we'll be removing the laser after it strikes the asteroid. We'll have to use a different variable, j. So j will equal the ship dot lasers.length minus 1. J is greater than or equal to 0. J minus minus. Let's grab the laser properties. So Lx will equal ship.lasersj.x. And the Ly, the laser y, will be just the .y one. So we've got all the properties now. Now we need to detect hits, or to say detect hits. So what happens? How can we determine that? Well, let's use a condition. So if the distance between points, that's one of the functions we made earlier on. So the x1, y1 is the asteroid x, the asteroid y. x2 is the laser x and the laser y. Now, if the distance between the asteroid and the laser is less than the asteroid's radius, then we've got ourselves a hit. We don't need to worry about the radius of the laser. It's too insignificant. It's only small. So that's a hit. Now what do we want to do here? Well, we want to remove the laser. So that will be done with a splice command. So we can go lasers.splice, and in brackets we can go j, 1. And we also want to remove the asteroid. Well, there's more we want to do, but this is just a temporary placeholder. So we'll go roids.splice I, 1. So that should remove the laser, remove the asteroid, and we don't need to continue cycling through this for loop. Once we've detected a laser striking the asteroid and it's destroyed, we can break this. Break. Let's give that a go. Right, so there's some asteroids. Let's shoot one. Good. It's disappearing. There's another one. Bang. Bang. Now, in the original game, when you shoot one of these big asteroids, it actually breaks into 2 medium-sized asteroids, and then when you shoot a medium-sized asteroid, it breaks into 2 smaller asteroids, and then finally when you shoot a smaller asteroid, it's dead. It's completely dead. So we'll do the same sort of functionality. I'm thinking we should have a method call here, say destroy asteroid. Now the reason being, we'll pass its index. The reason being is that there's also another situation that we can destroy an asteroid. That's if we ram our ship into an asteroid, it also gets destroyed, like a kamikaze pilot or something. Now if we go up to our new, where we create the asteroid, so new asteroid, because we're going to have various sizes, I'm thinking that we'll need to pass the radius in here. Right, so we'll have to find out where we're calling this so far and update it. So new asteroid, we'll pass that instead. I'd like to keep these as integers because we'll be using them as to compare to figure out what size the asteroids are. So we'll just do a maths.cl there. Because this roid size is, we don't know what that could be. Somebody could set it to 77, right? So there could be a fraction there. Good. Now let's create the destroy asteroid function. Now it will take the index, won't it? That's what we passed earlier. Destroy asteroid. Let's grab some of the properties first. So the x value will equal the roids index. That's the index being passed. Dot x, and we'll grab the y component. And we'll also grab the, what else do we need to know? The radius? I think so. Of course we need to know the radius because we need to split the asteroid in 2, if necessary. Remembering only the bigger ones need to be split, necessary. So if the radius equals, so if the radius of the asteroid being hit is equal to the, basically this, That means it's the original size, the biggest size. If it equals that, we need to split it into 2. So how we can do that is just go roids push new asteroid, and it requires x, y, and r. So the x will be equal to the same. We'll just set it to the same point. So x, the y will be the same. The radius will be half the size. So we'll divide by 4 instead of dividing by 2. Okay, and we want to do that twice because they split into 2. Now, naturally, because we're calling this new asteroid method, they'll also have random velocities and so on. So that'll be fine. Else, if r equals, now if it equals this here, that means it's a medium one that's been hit. If it equals that, we want to do a similar sort of thing. So we'll just copy all that. But we want to break it into even smaller pieces, so divide by 8 at the same location. And finally, destroy the asteroid. So the original asteroid that's been split, that's just where we can go roids splice. Roids splice. Now the start number is the index, and we just want to remove 1. Destroy index. We also want to call this, don't we, elsewhere. Let's call that where our ship smashes into something. Draw the lasers, detect hits on the asteroid. Check for asteroid collisions when not exploding. Yep, so when we explode the ship, we also want to destroy the asteroid. Now, which number asteroid? It'll be equal to I here. I. Let's give it a go. Hopefully it'll work. So first of all, where's an asteroid? There's one. Shoot it. Great. It's splitting into 2. The medium one's splitting into smaller ones. Now how about the smaller ones? Yep, they're getting destroyed. Awesome. Amazing we got that right first time round. So it seems to be working really well, except that we just need to test whether ramming one of them will destroy it. Bang, it did. Now will this split into 2 if I ram it? Awesome. Try it with a bigger one. Cool. There's just one issue that I've found, is that sometimes when you smash into it, you destroy more than one asteroid, especially when you're invincible. Like that. See, that the reason for it is that it's because it's cycling through all of the asteroids. So that's not right. All we need to do to fix that, though, is break there. So once our ship has exploded, it no longer continues destroying asteroids. Try that one more time. So when you're invincible and inside something, yeah, that's better. That should only break in, that should break into 2. Yep, awesome. Great. There's just one last thing I'd like to do in this tutorial, and that's to create some graphical effect when the laser strikes an asteroid. So go right at the top, we'll set a duration for the laser explosion. So probably similar to this here, ship explode duration. We'll have a laser explode duration. Let's set it to say a bit smaller, say 0.1 of a second. So duration of the laser's explosion in seconds. Right, so we'll have to give our laser a property called explode time. So go down to where we shoot the laser. We'll add a property called explode time, and it'll start off at 0, so that means it's not exploding. There is no more explosion remaining. Now go down to where we draw the laser. Draw the lasers. Right. So here we want to say if ship lasers I dot explode time, if that equals 0, that means we're not exploding, and we'll just draw the normal laser beam, laser ball. Else, this is where we'll draw the explosion. Draw the explosion. So it's just going to be some concentric circles similar to what we did with our ship when it collides with an asteroid. How about, well, let's see what we can do here. How about we base it off the ship's radius times by, say, 0.75. We'll do this a few more times. 0.5 and say 0.25. We'll just have two, because it's going to be a smaller circle, we'll just have 3 concentric circles. And the colours, well, they'll be based off this one. How about, I looked some of these up before. Orange, red, salmon, and I think pink was a nice one. Then we'll have to go down and set the explosion time. So where we're detecting the hits, we don't want to remove the laser at this point. So we can go ahead and delete that. We want to destroy the asteroid and activate the laser explosion. We can do that just by setting the property. So ship lasers, J, isn't it? Yes. J dot explode time. That will equal the ceiling, so the rounding up of the laser duration, the explode duration, times by the frame rate. We also only want to run this if all of this, if all of that equals 0, that means we're not exploding and the distance meets that requirement. Then we'll destroy the asteroid and activate the laser explosion. Finally, we need to decrement the explode time. So go down to where we move the lasers. We also don't want the laser to be moving when it's exploding. So here we can handle the explosion. So if ship.lasers I, if the explode time is greater than 0, that means we're presently exploding, doesn't it? Else, we want to move the laser and calculate the distance. We don't need to do these things when we're exploding. So we'll decrement the explode time here. So just minus minus, explode time minus minus. And then we want to destroy the laser after the duration is up. So if explode time equals 0, then we will ship.lasers.splice I, 1. So we'll just remove the ith laser. And we'll just use the command continue here to prevent it from going over the remaining code. It'll just jump back to the next iteration of the for loop. Hopefully that should work. Let's take a look. Cool. So we've got ourselves a little blast radius. It looks pretty nice. It's working. Let's see if we can crash into an asteroid. Great. Bang, bang, bang. Looking pretty good. So in this tutorial, we're going to implement new levels, a lives system, like give the player 3 lives, and a game over screen. Right. You can go ahead and download this code if you like from the link below. First of all, let's go down and create the skeleton of what we want to do today. So just where we set up our ship and roids and so on, how about we make it more generic? Set up the game parameters. Right, so we'll declare our variables. We'll need a level, the current game level. We'll put our roids here as well as our ship. And we'll create a method called, say, new game, because we'll have to call that after our game over. So all this stuff we'll put in another method. So go down and create the new game method. New ship, that'll do. Function, new game. And it will create our ship. We don't need to set up the asteroids because they're created inside this create asteroids method. We'll probably need a new level method because after each level we'll call that. And inside the new level method, we will call that create asteroid belt. So it can just go straight after here. Function new level. And all we want to do currently is create the asteroid belt. Just make sure we haven't broken anything. Yep, that's looking fine. So inside the new game method, we'll want to set up our level, our initial level, so it can start at 0. Now what does level do? Well, I'm thinking probably inside our new asteroid method, we want to speed up. We want to make the asteroids go incrementally faster. So how about we create a variable called level multiplier, and that'll be equal to 1 initially, plus say 0.1 times the level. So as the level increases, this will slowly go up, this level multiplier. And we just want to multiply our base roid speed by that level multiplier. We want to do that in both the X and Y direction. Good. And also where we create our asteroid belt, up the top here, we want to increase the number of asteroids. So we can just go where it says I is less than roid num, which is currently 3, we want to add the level each time. So at level 0, it won't affect it. But at the next level, it'll add 1, and so on. Currently it won't do anything, well, not obvious. So we can test it by changing that initial level back down in the new game. Set it to say level 10. Yeah, you can see that there's more asteroids and they're faster. So if we set that to level 20, there's lots and lots of asteroids going very fast. Good. Just set that back to 0. Now we need to increment our level. So when do we do that? Well, it's when the final asteroid is destroyed, isn't it? So go up to our destroy asteroid method. Can you see that the final line is to remove it from the array? So all we have to do is do a simple check there. So new level when no more asteroids. So we can just use if roids.length equals 0, then we want to increment our level, level plus plus. We also want to call a new level. Simple enough, let's give it a go. I'll just change the initial number of asteroids so I don't have to shoot so many. Roid num, we'll change it to 1. Right, so when we destroy this asteroid, we'd expect it to go to a new level with 2 asteroids. Where's that asteroid? Sorry, I'm not very good at this game. There we go. And there's 2 new asteroids. Awesome. And we've destroyed both these asteroids. There should be 3 on the next level. And they'll be going slowly faster. That'll be hard to notice, but that's okay. It's an incremental thing. Come on. There we go. And there's 3 asteroids. Awesome. I'm thinking, wouldn't it be nice if we had some text between levels showing the current level number, just to give the player some indication? And we probably want to make it fade out as time progresses. So how about we create 2 variables down where we're setting up our game variables, one called text and one called text alpha. So alpha will be the transparency component of our text. And we'll also need 2 constants. How about we call the first one text fade time. Set that to something, a couple of seconds, 2.5 seconds say. And that will be the text fade time in seconds. And we'll also want one called, say, text size. We'll put it in pixels, choose a number, say 40 pixels. This will be the text font size in font height in pixels. Right? Now where are we going to set these up? Well, probably at the start of the level. So we'll go down to new level. New game, new level. So text will equal what? We want to show level plus the current level. So it'll be level plus, now remembering we're starting at level equals 0. We don't want to display level 0. So we'll add 1 to this. So that'll be level plus 1. And the text alpha, we want to start at full opacity, so that'll equal 1.0. Text alpha takes a number between 0, transparent, and 1, opaque. So to draw the text, we'll want to go down to our update function. How about we draw the text last so that it appears on top of everything? So after we draw our lasers, I believe, draw the lasers. Just after that, we'll say draw the game text. Now we only want to draw this when the text alpha is greater than 0. So text, it probably wouldn't matter if you didn't check for this, but we will. So if text alpha is greater or equal than 0, then we want to draw our text. So how about we give it a color first? So context.fill style will be a color. Now we want white, but we also want to set the alpha component. So to do that, we can go RGBA bracket. Now white's just 255, 255, 255. And after that, we need that alpha component. So we can just add to the string our text alpha. And then we'll also have to close that, the bracket, the parenthesis. Okay, we'll also want the font. So the font will equal, well, here we can add a whole bunch of strings, but you can put the style. How about we put, just as an example, put small caps. We'll need the size of the font, so we've already decided that. So text size. Now that's in pixels, so we'll have to put px after it. And we need the type of font. So we'll put Deja Vu, Sans, Mono. I mean, you can put Arial there or Century New, whatever your favorite font is. Right, now we'll need to draw the text now, so that'll be fill text, the fill text command. It requires a text string, which is just text. The X, we'll say it's halfway across the screen, so canvas width divided by 2. And the Y component, we could put it in the middle of the screen, but then that'll be over our spaceship, so that's probably not good. How about we put it, say, 3/4 of the way down the screen? So canvas.height times 0.75. And finally, we need to decrement our alpha. We want it to slowly fade out. So that'll text alpha minus equals. Now it starts at 1.0, but we'll have to divide that by our duration, so text fade time. And we'll have to take into account the frame rate, so divide by FPS. And we'll probably have to bracket all that so that it treats it as a single thing. Let's give that a go. Oops. Level 1. Well, it's appearing and it's disappearing. Just the location of it's not very good. We just need to center it. So we can do that by going context, text align. The align will be in the center. And we could also align it vertically by saying text based align equals middle, I believe. You can look all these up. Let's give that a go. Level 1. Great. So if we destroy this asteroid, will we get to level 2? And will it show the text? My shooting skills need improvement. There we go, level 2. Good. I think that's enough of a transition between levels. Next, we'd like to deal with the game lives. So we'll start with probably 3 lives. So let's create a constant to represent that. Constant game lives will equal 3. That's the classic number, but you could set it to 5 or 7 or whatever. So starting number of lives. And we'll also need a variable to keep track of current lives. So L, just call it lives. Inside our new game method, we can initiate that. So lives will equal game lives. And we'll also want to draw some graphical representation of these lives, which is usually just the ship itself in the top left corner. So go down to where we draw, probably just after we draw the game text. We'll draw the lives. So we'll have to use a for loop here. So var I equals 0, I is less than current lives, I++. And we'll have to make a method here, say draw ship. Because we already have drawn our ship, we don't want to repeat the code here. So we'll go ahead and make that method, find out where we draw our ship first. Here we go, so draw the triangular ship, just this code here. We'll cut that. Now we'll need to know separate X and Y location because the ship moving around the screen isn't going to be the same X and Y location as the lives. And probably the angle is important too. So we can go draw ship. We haven't made this method, so I'm just preparing it. Draw ship, say ship.x, ship.y, and its angle. So x, y, and the angle. Let's go ahead and create that method now. So just after dist between points, function draw ship. Now we need an x component, a y component, and an angle. And inside there, just paste what we had on the clipboard. I'll just have to update this to match the parameters there. So the line width, the style, that's all good. The x and y will just be the x and y. We don't need ship prefixing it. So just go ahead and delete all that. X, y, and also our angle. So it's just going to be A. So we'll have to delete all the ships before the A's. A little bit of a tedious process, but well worth it. It'll save us time in the end. There we go. And all we have to do now is update that new, inside the lives, we just need to update what X, Y, and A are. So that should be okay where we draw the actual ship. Now inside lives, we need an X component. Well, I'm thinking it's going to start at the ship size. So it means we'll have some sort of margin. But as we draw across the screen, we'll have to multiply. So we'll say we'll add I times the ship size. And we want some space between each ship. So probably just say times by 1.2. That's the X component. Now the Y component will be, I think, just the ship size. Doesn't have to be very much, I don't think. And the alpha, well, it's going to be 90 degrees. Now, in radians, 90 degrees is 0.5 times mathpi. Hopefully that should work. Let's give it a go. Yeah, that's looking pretty good. So we can see our lives up there. The only issue is that nothing happens. If we crash, oh, I just want to crash. Nothing happens because we haven't implemented any code to decrement the lives. How about we reduce our lives after the ship has exploded? So just go down a little bit where we reset the ship after the explosion has finished. And here we can decrement our lives. So lives minus minus. And we may as well handle the situation where lives equals 0. So if lives equals 0, so that means we'll be finished the game, we can just call a function called game over. Game over, man. Else we'll just do what was already there. The ship equals new ship. So let's go ahead and create an empty game over function. So just after explode ship, function game over, and we'll leave ourselves a to do here. To do game over. Let's give that a go. So if we crash into this asteroid, we expect the ship to disappear, after the explosion. Awesome. To make that look really nice, how about we change the color of the ship, the life ship that is, as we strike the asteroid, just to give it a little bit of a graphical indication. So to do that, we can go down to where we draw our lives. Okay, draw the lives. How about we create a variable called, say, life color? And we'll set that dependent on the situation. So life color. Now, when the ship is exploding, that means we've struck an asteroid. We want it to be a different color, but only the last life, the final life of this series. So exploding and I will equal lives -1. That'll be the last one. Okay. If all of that is true, then let's set it to say red. Else we'll set it to our normal color, white. Now how are we going to pass this? We've already got this method drawShip. How about we give a fourth parameter called color? So we'll just pass life color here. Now we're already calling this elsewhere. We could go ahead and update, the color for each single call, or we can just set a default, make it optional. So go to our drawShip function declaration. We can say the fourth parameter is a color, and we can just go equals white. And what that does, if they don't provide a color, it'll automatically assign it as white. It'll be a default color. And just down here, we can go color. So let's give that a go. So hopefully we should get that first life turning red when we strike this asteroid. Great. So it turns red and then disappears a few moments later. Awesome. The last thing that we'd like to do in this tutorial is implement the game over function. So how about we set a property on the ship, something to indicate that it's no longer with us. So how about ship.dead equals true. We'll also want to set some text to let the player know that the game is over. So game over, text equals game over. To make that work, we'll have to set the text alpha. Text alpha will equal 1.0 full opacity. So we'll go down to the new ship method and put in that dead property. So dead, it'll start the game as false. We don't want them to be dead to begin with. Let's give that a go. So if we crash our ship 3 times, hopefully it'll show a game over message. Come on, there we go. Game over. The only thing is that we can still move our ship around, so that's no good, is it? So to handle that, we can go up to our event listeners. So key down, in the key down method, we want to say if ship dead, just return. So that means it won't access any of the code below. It won't allow the user to do anything with the keys. And similarly in the key up method, just paste that in there. Right. Also, we don't really want to draw the ship, do we? It should be dead, so it shouldn't be there anymore. So down in our update function, where we draw, so the asteroids are okay. Thrust the ship, we don't want to do that. So if ship thrusting and not ship dead, so the ship is alive, we'll thrust and draw the thruster. Draw the triangular ship. So if blink on and not ship dead, we'll draw the ship. Now the lasers are okay, the game text and all that's okay. Draw the lives. Probably we don't want to detect asteroid collisions anymore. So if ship blink number equals 0 and not ship dead, we'll detect asteroid hits. Right, let's give that a go. So crash your ship 3 times. Bang. Bang. And final one. Game over. And I can't control the ship. There is no ship. Good. Finally, we'd like to reset the game after some period of time. How about where we're checking for text alpha, so that game over message will appear. How about when that finishes? So we'll say else if ship is dead. So that means only when the text disappears and the ship is dead. So they'll be at the end of game, definitely. we will say new game. New game. Let's give that a go. So smash into the asteroid. Bang. Smash into the asteroid again. Bang. And one last time. Let's see what happens. Game over. The text disappears and we start again at level 1. I think that's pretty good. And that'll do us for today's tutorial. So today we implemented lives and resetting the game and level up and so on, increasing the difficulty. So wouldn't it be nice if we had a scoring system? So first of all, let's create some constants to represent how many points each of our asteroids are worth. So roid points large. Now in the original game, the large asteroids were worth 20 points, so we'll do the same thing. So this is the points scored for a large asteroid. So go ahead and copy that a couple of times. We also have medium asteroids worth 50 points, medium. And we also have small asteroids worth 100 points because they're the hardest to hit. We'll also need a variable. So go down to where we declare our variables, called score. That'll be our current score. And in this new game method, we'll want to reset that to 0. So put that in there, score equals 0. Now where will we increment our score? Well, that occurs when we destroy an asteroid, doesn't it? So go up to our destroy asteroid method. Here we go. And in where we deal with our large asteroids, we can simply go score plus equals roid points large. We'll do a similar thing inside the medium part of this statement. There we go, score plus equal roids points medium. And to handle small, we can just simply put an else in here. Else, if it's not medium or not large, we'll add the small points. Now let's go down and draw the score. How about we put the score in the top right-hand corner of the screen? So just after we draw the lives, we can draw the score. And let's copy and paste some of this code up here to draw text. Okay. So the text align, because we're on the top right-hand corner, we'll change that to right. The baseline can be middle, that's fine. The fill style, we just need plain white. We don't need to change the transparency. The font, we don't really need small caps because it's only going to be numbers. The text size, pixels, stage over sans mono is fine. Fill text, we'll be filling the score. The position will be the canvas width, but we do want a slight margin, so let's base it off our lives margin. So this is ship size, so we'll have ship size divided by 2 because the ship is the center of the ship. Ship size divided by 2. And the Y position will be the same, exactly the same as our ship. So ship size. Let's test that. Great, we have a 0 in the top right hand corner, that's promising. Let's shoot one of these big ones. We get 20 points, that's good. Now a medium one. Oops, I shot another big one. Medium one was worth 50 and a small one should be worth, that should bring us to 190. 340. Yep, that's working well. Now how about in the middle, the top middle of the screen, we put a high score. So let's go ahead and create a high score variable. So head back up the top and declare that variable. So just next to where we declare the score, we can also say score high. And inside our new game function, how about we initialize that, score high. Now ultimately we'd like to grab this from somewhere, like a saved location or something. But just to begin with, let's just set that to say 100, just to make sure that it works. Where will we handle the high score? Well, up in our destroy asteroid method, where we're incrementing the score, just after we do that, how about we do a check? Check high score. And that's simply going to be a condition. So if the score is greater than the high score, then we want to set the high score to equal the score. So score high will equal score. Of course, we'll need to draw that, so head back down to where we draw our score. Draw the score. We're going to do a very similar thing with the highest score. Draw the high score. The text line is going to be the center because we want it in the top middle of the screen. Text baseline is fine. The fill style is white. The font is, how about we set this to a bit of a smaller font so it doesn't take away from the current score. So we'll say times by 0.75. Just put that in brackets. Otherwise the font is the same. The fill text will be the score high. The position will be the middle of the screen, so it'll be the canvas width divided by 2, and it'll be the same Y component. Let's test that. Okay, the 100, it's not exactly in the center of the screen, is it? Ah, that's a spelling. I've got the Australian spelling, not the American spelling, so center with an ER. Let's just double check that. Good. I'm thinking we'll probably need some sort of text before that, so maybe say, I'm going to use the word best, but you could use high or top or whatever. Best plus the score high. Let's see if that looks okay. Yeah, that looks okay. Now let's test to see if it works. So we'll be trying to get more than 100. There we go. So it's updating to match the highest score. Obviously, the biggest issue is that when we reset this, it goes back to 100. We'll want it to persist between browser sessions and indefinitely, basically. So how can we do that? In the past, we would have used cookies, but with HTML5, we can use local storage, local web storage. So zoom back up to our new game method where we set the high score. We can just write local storage.getItem. Now this getItem function requires a key, which is a string, like this is like a save key. Now this only has to be unique within our code. It doesn't have to be unique across all our software or whatever. I believe it's based on the URL. So let's create a constant. Prefix it with save key, score. So it's just a string. We can call it, for example, high score. And this will be the save key for local storage of score, of high score. Good. Go back down to new game. Put that in there, save key score. Let's see what that does. Right. So when we haven't set it yet, it comes back null. So we'll have to check for that. So how about we pull that down just underneath where we do all this. Ship equals new ship. Get the high score from local storage. So how about we create a storage string. So score string will equal all of that. So that's our string. Now if that string, if score string equals null, then we want to set the score to, so set the high score to equal 0. That means they haven't set a high score yet. Else, we want to set this high score to equal the score string. But because it's a string, we'll have to pass int. So pass int requires a string, which is just the score string. Hopefully that will work. Let's give it a go. Best is 0. Now, although the score is going up, if we reset this, it's not storing it, is it? So we'll have to store it somewhere. So up where we increment our score and test for the high score inside our destroy asteroids method, so check high score here, we can just set it here. So we can go local storage, set item. We need the key, so the save key. save key score, and the value will be the high score. Score high. And hopefully that should be everything. Right, so we've currently got a best score of 0. Now we put a best of 20. Let's reset. Yeah, it's persisting. So that should persist between browser sessions, between games, between everything. So let's try again, 190, reset. Good. And let's, just to make sure it's really working, how about we destroy our ship? So we should have a high score. Let's get a high score first. 310, 410. Let's smash the ship a few times. 460. 560, and one more life left. 610. So this should reset. Yep, the score's reset, but our best score is still 610. Great. So in this tutorial, we're going to learn how to add sound effects to our game, and music to some extent. First of all, go ahead and download the sound files from the link below. I'll link to a zip file. It's important that you extract the sounds directory to the same location as the HTML file. So I've just created a folder called Asteroids here, put in both the code and the sounds folder. That's important because we'll be referencing this directory inside our code. So inside the sounds directory, there'll be 6 sounds: explode, hit, laser, music high, music low, and thrust. I just used the program Audacity to create those, but I won't show you that here. We can save that for another tutorial. So go ahead and open our code. So head down to where we set up our variables. So just after we set up the canvas, let's set up sound effects. So it's a pretty simple process. We just need to create a variable. Let's prefix all our variables with fx, just to make it clear. So fx laser will equal new audio. And just inside there, we'll need a string for the source. So that'll be the directory name, sounds / the name of our file. So laser.m4a. Now, where do we want to call that? Where do we want to play that sound? Well, in the laser method, don't we? So just head down to where we press the spacebar. There should be a shoot laser method. Now within that if condition, all we have to do is go fx laser dot play. And because it's a function call, we'll need the parenthesis. Let's give that a go. Okay, a couple of problems. First of all, it's quite loud, so we can fix that up in code. And secondly, when I push the spacebar continuously, it's not playing every shot. So watch again. So although I fired about 10 shots, it only played it about 3 or 4 times. That's because when the sound is playing, and I call another play method, it won't play it until it's finished. So that's a problem. We can fix that up though. So head back up to where we create our audio. Currently, we're using this inbuilt object or inbuilt class called audio. How about we create our own custom object called sound? It will behave exactly the same way. We'll make sure that it does. Go down and create that. Let's create it just before our update function. So function sound. The first parameter will be the source. Now, the second parameter, how about we create a parameter that handles multiple concurrent plays of our file. So let's call that max streams and set its default to 1. That's currently the behavior we're experiencing now. So when we push the space bar multiple times, it will only play 1 sound at a time. And we'll also want to set the volume here. Now volume takes a value between 0 and 1. So how about we give it the default value of 1, which is maximum volume or normal volume. So we'll have to keep track of which stream we're currently playing. So we can go this.stream num equals 0. And we'll also need to keep track of each stream. So that could be handled by an array, for example. So this.streams will equal an empty array. Now to populate that array, we can just use a for loop. So for var I equals 0, I is less than max streams, I plus plus. So we can push to that array. So this dot streams, we'll have to prefix all our variables here with this so that it's referring to the objects variable. So this dot streams dot push. Now all we have to push is a new audio object. So new audio, and it takes the source as an argument. And we may as well set the volume here. So this dot streams I dot volume will equal vol. That's what we're passing up here. That should set that up okay. Next, we need to implement the play function. So we can handle that by going this dot play will equal function. Now we'll need to increment the stream number so that we cycle through each of the streams. So we can do that by going this dot stream num will equal, put this in brackets, this dot stream num plus 1, incrementing it, and find the modulus of the max streams. I'll explain that soon. So then we'll call we'll find that element. So this dot streams, the element number will be this dot stream num, this dot stream num dot play. So that's just the inbuilt play function. So for example, if max streams equals 2, right? So this stream number 0 plus 1 is 1. 1 modulus 2 is 1. So that will play the second element of our streams array. When this function is called again, so stream number is currently 1 plus 1 is 2. 2 modulus 2 is 0. It'll play the first element of that array. So in essence, it will cycle through. It will cycle through playing each of those elements, each of the array's elements as the play function is called, which is what we want. So let's test that. So currently it's max streams equals 1. It behaves exactly the same way. So let's head back up to where we call our initial laser sound. Here we go. And give it some arguments. So the number of streams, let's try 2. And the volume, let's turn it down a bit to say 0.5. Right, so the volume is okay. Now if I push the spacebar as fast as I can you hear that it's only playing 2 of them? That's because our max streams is 2. So what's a realistic number we could set here? How about 5? That's probably fast enough so the player wouldn't notice. Let's try it. I think that's pretty good. It looks pretty realistic to me. Awesome. Next, it's just a matter of implementing our other sounds. So let's copy that and implement fx explode. So that's where our ship crashes into an asteroid. Just update the source to sound/explode.m4a. We'll delete, we won't use any arguments here. We'll just use the default ones. Now where will we call fx explode? Well, explode ship comes to mind. Where are we? Draw explode ship. So just after that, fx explode.play. Let's give that a go. So if we crash, yeah, that sounds pretty good. It's not too loud, I don't think. Great. Head back up to our audio. Let's create another one called FX hit. So this is where our laser strikes an asteroid I should say. Sounds hit. Again, we'll just leave the default sound. Make sure that actually we'll probably need to increase the max streams. The reason being is that we could, in theory, hit a lot of asteroids at the same time because we're firing out lasers in quick succession. So how about we give that the same number of max streams as the FX laser? And where will we call that? Well, probably when we destroy our asteroid. That's probably the right time to do it. So how about destroy the asteroid FX hit dot play. Sorry, that was just the background ship blowing up. Let's give that a go. So when we shoot an asteroid, yeah, that sounds all right. So we're shooting out a lot of lasers, and we can hear some simultaneous hit sounds. Cool, that sounds all right. I'm just thinking, to stop us hearing background explosions all the time, let's create a global flag called, for example, sound on, and we'll only allow sound when that flag is set to true. So there's an explosion, for example. So if sound on, then we will play the sound. If sound on, then we will play this sound. Let's go and create that flag now. So just under where we show, for example, sound results and so on, create a constant, sound on, and that will be equal to false. So let's just run that, make sure it's working. Yeah, so no sounds will be heard while we're programming. Next, let's implement the thruster sound. So just where we're creating the other sounds here, let's go fx thrust will equal sound slash thrust. We probably don't need any parameters here. Now where will we call that? Where will we play that? Probably down in the update method. In the update method we thrust the, here we go, thrust the ship. So just up near the top there, fx thrust.play. And when we release the thruster key, when we release the forward arrow, we'll probably need to stop that thrust sound as well. We don't want it to continue onwards. So how about we, in the else part of the condition, we go fx thrust.stop. So we'll have to implement this method. So fx thrust.stop. So go to our sound function and create a new method called this.stop will equal function. And all we'll do there is call the inbuilt pause function. So this streamnum.pause, and we'll want to reset back to the start of that stream. So we can do that by going this.streamnum.current time equals 0. So that'll set the cursor or whatever it's called back to the start of that stream. Let's give that a go. Oh, we'll have to turn on our sound first to test this. So sound on will equal true. Yeah, that's working. And our thruster is working. Cool. Good, that's all our sound effects done. Next, let's create some music. Just set that sound on back to false so that we don't have to listen to explosions in the background. Okay. Now music, I use the word music very loosely. So just under where we set up the sound effects, set up the music. Now the music in Asteroids, the original game, was pretty much just two tones. It was going boop, 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 something like that. It's just kind of two different tones. So why don't we create a variable called music, and that will equal, we'll have to create a new object. It's called music, for example, and it will take the two sounds. So we'll have sounds music low, and the second parameter will be similar, sounds music high. So just the two sound files that we have. One's a low sort of tone and one's a high tone. Let's go down and create that object just near where we create our sound objects. New shoot laser, so just here. Function music. So we'll have source low and source high. So first of all, let's declare our variables. So we'll have two sounds. So this dot sound low, which will equal new audio source low, right? Similarly, we'll have this sound high, which will equal new audio source high. And we'll also need to keep track of which sound are we currently playing. So we can just use a Boolean for that. So this dot low will equal true. That means we'll start with the low sound. And we'll also need the speed of the music. The reason being is that as the game progresses, the speed of the music increases. So this dot, say, tempo will equal 1.0, say. And we'll define that as seconds per beat. We'll also need to somehow count down that tempo. So we can create a variable called this.beatTime. We'll set it to 0 to begin with. And that's basically defined as the frames left until next beat. Right, we'll have to create our play function. So this.play equals function. And what will it do? Well, if this dot low, we want to play the low sound. So this dot sound low dot play. Right, and otherwise, so else we want to play the high sound. This dot sound high dot play. Okay, and we also want to switch between those two. So we can handle that by going this dot low will equal not this dot low. So we're just switching true to false and false to true. Okay, good. We'll also need some way to count down this tempo as such, the beat time. So how about we create a function called this.tick. This.tick equals function, and this will be called every frame. So knowing that, we can say if this.beatTime equals 0, that means it's counted down, which it will have immediately. We want to play the current sound. So this.play. We also want to reset the beat time. So this.beatTime will equal the ceiling. So we want to keep it as a integer. Math.ceil of the tempo. So this.tempo multiplied by the frame rate. So for example, if the current tempo is 1, the frame rate is 30. So we'll have 30 ticks until the sound is played. So that's 1 second. That sounds good. Now else, so it doesn't equal 0, we want to decrement it. So this.beatTime minus minus. Now where do we call this tick? Well, we need to call it in the update function. So just go down to the update function, up near the top, tick the music. So we can just go music.tick. Now hopefully that will play our music. Let's try. Okay, it's not playing. Let's see what's wrong. Let's head up to the top and see if everything's okay where we create our music. Music equals new music, sound music low. Okay, I forgot to add the extension to each of these music files, which is important. But luckily the game didn't break, so I'd say our code is all correct. Let's give it a go. Great, that seems to be working. That reminds me, we should probably put in a global variable, a global constant, music on. And we can just go down to our music method, and in our play we can just say if music on, then we'll do all of that. Good. So we've turned our music off. Now how will we make the music go incrementally faster as the game progresses? Well, let's head up to where we declare our music variable and create a couple more variables, one called roids left and one called roids total. And we'll find a ratio of how many there are left to the total and use that as a guide. So just in our create asteroid belt, how about we set up the roids total? Roids total will equal the roid num. But remember, each of those big asteroids can be broken down into two mediums, and each of those mediums can be broken down into two smalls. So we'll have 4 smalls plus 2 mediums is 6, plus the original big one is 7. So roid num times 7 will be the total. And we'll want to make roids left equal to that. Roids left will equal the roids total. Actually, that should be the roid num plus the level, shouldn't it? Because you see down here, the number of asteroids is dependent on the level. So all of that times 7. Right, that should be okay. So head down to our destroy asteroid method. And just after we play the sound, let's calculate the ratio of remaining asteroids to determine music tempo. So first thing we'll need to do is roids left minus minus. We'll decrement that. And then we want to call a function on music, for example called set asteroid ratio. And then in there we can calculate the ratio. The only thing I can think of is if the roids left equals 0, then so roids left equals 0. If that's true, well, the ratio is going to be 1. We want to reset the ratio to just 1. Else, we will find the actual ratio. So roids left divided by roids total. So head down to our music object, music, and we want to create that method. This.set asteroid ratio equals function. We'll need to have an argument, have a parameter here called ratio. And this will modify our tempo. So this.tempo will equal the starting tempo minus 1.0 minus the ratio. Because when the ratio is, for example, 0.9, 1 minus 0.9 is 0.1, 1 minus 0.1 is 0.9. Yes, that's fine. The only thing I can see, the only problem I can see here is that this is going to get very small. So it'll become too small where we'll be playing hundreds of beats per minute. We don't want that. Per second, I should say. So let's multiply that by some factor, 0.75 times that. Right? So that means when the ratio is 0, 1 minus 0 is 1, 0.75 times 1 is 0.75, 1 minus 0.75 is 0.25. The fastest rate that we can go is 0.25. That's 4 beats per second. Okay, we'll just need to go turn on this music on function. Sorry, music on flag. Set that to true, and let's give it a go. Okay, so that's 1 beat per second. Let's destroy some of these asteroids. Yeah, it's getting faster. Let's just play until we get to the next level. Great, it's reset. Perfect. Let's just turn on the sound to have one final play. Great, that's working well. And that's the end of this tutorial series. I hope you've enjoyed it just as much as I've enjoyed making it. So we've created a little triangle that can fly around space using the arrow keys. We can press the space bar to shoot a laser. We've created randomly generated asteroids that float through space. We've added a scoring system with a high score that saves to the local storage. And we've added sound in this tutorial. I'll post a link to the final code in the description below. Feel free to download it and have a play with it yourself. You can, for example, change some of these parameters, or maybe you can add some new functionality like power-ups that float across the screen that your ship can collect. Things like invincibility or an extra life. Maybe a split laser that shoots out multiple laser blasts at once. The only limit is your imagination. And that's what programming is for me. To learn something new, to create something wonderful, and to have a lot of fun along the way. Until next time, talk to you then. Cheers.